Welcome to our virtual science lab. My name is Miss Bruin, and for the next few lessons, we will be exploring waves together. So, the first thing I'm wondering is when you hear the word wave, what does it make you think of? If your mind went straight to water, you're exactly right. We are investigating water waves together. So, I thought I could share with you when I was about your age, this is something that I love to do. And I didn't even know that I was making waves. My brother and I used to walk down to the Hudson River and throw rocks in the water. Watch what happens. Do you see what's rippling outward? Those circles. They're not really circles, though. They're actually mini waves. I had no idea that I was even making a wave by throwing rocks in the water. So my question for you is, where have you seen, made, or felt water waves in your life? You could think about the tub. You could think about throwing ice cubes into a glass. What else can you think of? So when I was your age, I have to admit I wasn't a great scientist. I never really stopped to observe things. It's something I've had to train myself to do. But when we observe these waves, I'm noticing things that get me kind of curious. Like, how high can a wave get? Why are waves different heights? Like, why are some of them soft and calm and quiet and small? And why are others gigantic and violent and scary? I'm also wondering, I don't think I've ever been to the beach and seen the ocean still. So are waves like a constant thing? And if so, what causes them? As you're starting to look a little bit more closely, I'm sure there are questions that you have about waves as well. What are they? So, in order to describe waves, I have some words that you're going to need. These are words that scientists use to describe waves, and it's going to help us to compare different waves, to look at their different qualities. And the first one is the word crest. So, the crest of a wave is somewhere up here in this real life picture. It is the highest point that a wave reaches. That is the crest. The trough is actually the lowest point that a wave reaches. So if we're looking at this real life picture, right, we're not seeing where the trough is. And it's hard to see in real life because it's underwater somewhere. Waves go up, reach their crest, and then come down. And the trough is the lowest point that they hit. So if you're looking at the diagram here, the wave's trough could be found right here on this wave if you're looking at my little red pointer. Another term that's really important that helps us to describe the wave is the amplitude. And the amplitude is the height from sea level, which is when the water is at rest, all the way up to the wave's crest, that highest point. And wavelength might be another useful term that we could use to describe waves. And that's just the distance of one full wave cycle, one complete wave cycle. So from one wave crest, following it all the way down to the trough and back up to the next crest. That distance we call the wavelength. And frequency is related to the wavelength. And frequency is the number of waves in a specific amount of time. So if we think back to those videos, right? One of those videos had small waves coming a little bit more slowly, right? And the other video had a huge, massive wave, probably with a much larger amplitude, that were coming faster. So We can think about what some of these terms look like and sound like in real life and help ourselves get to really understand what they mean by looking at a model. Are you ready? So here's our model. And here we go. We're going to start putting some energy into this still water. And you can see that the faucet is dripping just like it would in your tub, creating waves. So that water is no longer still because of the energy that's coming from those droplets. And if I pause it, you can see that I can use this little measuring tape here to figure out what the wavelength is between two waves. So if I measure a whole cycle from crest to crest, it is about 2.8 centimeters. That's almost 3 centimeters, but not quite. So I can measure the wavelength here. This model's pretty cool. And then I can also up the frequency. So remember, frequency is like how many waves come in a certain amount of time. And so if I increase the frequency, you'll start to see those waves come faster and faster and faster. And you can see that if I actually check the wavelength, if I measure from crest to crest, when I increase the frequency, the wavelength shortens because we're getting more waves more frequently. So the wavelength becomes a little bit shorter. It's about 1.5 centimeters or 1.6 centimeters, a little more than 1.5. Watch what happens when I increase the force or the size of the droplet. That's going to create a higher amplitude. Watch the faucet carefully. Look at that. So remember, amplitude is the height of each wave or the distance between when the water is still or at rest and each crest, each wave crest. And if I lower or decrease the amplitude, the waves become pretty tiny. So we could probably mess around with this and we could test some things out. Like maybe there's a connection between frequency and wavelength, right? When we increase the frequency, the wavelength shortened. When we decrease the frequency, the wavelength seemed to lengthen, right? So we could use this in a lot of ways, but it might help us to understand what these words actually mean in real life as we see water moving in this model. I hope you enjoyed our wave simulator. I'm going to leave you with some questions to think about. What new words can you use to describe waves? So until next time, look a little bit more closely when you drop an ice cube into your drink, or when you fill up the tub with water, or add a little bit more water because it's too cold or too hot. See what you can notice.